Okay, welcome to a tutorial on developing C++ apps for embedded Linux. In particular, the idea here is for target systems similar to a Raspberry Pi or the industry type systems that would essentially use the same processors and components that you learn when you're using a Raspberry Pi in a similar development kit. So we'll start with just our simplest application, printing Hello World. And to compile C++, you need a compiler, and that's G++, which if you don't have it installed, you have to install. And typically you can always do help for a command in Linux, and you will get a very concise explanation of how to use it. Sometimes I have examples. In this case, there's no example, but essentially what we care about are things like output, so the file that it's putting to. So we can do G++, in this case, source. App. Okay, so we'll now execute the app. And it says, hello. Now you'll notice if I instead try to do the same command, but compile it with a C compiler, it won't work. And that's why C is a subset of C++. That's why you need headers like, what is it? Standard IO. Each. And it's printf of C. Okay, so I believe it built then. So we'll run it. Hello from C. I didn't put a new line, so there. And these files here, just like in how in a Python project, if you were to control click, it would take you to essentially like a folder where your Python is installed that has all these standard modules. This is also a standard header file. So I just want to show where it actually is. Use find command, name. This is a regex expression, which will search for basically anything that includes stdio. And you can see that it's a header here. And this is important for later because when you make your own packages, you want them to show up to the developer the same way that standard headers show up. But before that, let's do an example where instead we'll print a different file. So how I'm going to do it is just simply define a simple class. Okay, so now we've turned it into a class, and it will achieve the same thing. It'll say hello. Okay, so now instead of the class, let's say we've been given this folder by someone else, and they have we got it from GitHub, so they have a header file now under implementation, and I have here it's going to print out hello from dependency one, because I eventually want to show like getting it onto an embedded device and how to manage dependencies there. So we go back to our file. We want to now include the files that were given to us. And let's say we try the original command, this one here. It'll say, oh, I can't find the header. If you go to the official documentation, you will see that you would read something like, oh, if I include it with this -i option. So this is the path to the folder where the header file is. Now it will find it, but it'll say, oh, undefined reference. So before it couldn't find the header, but now it found it, but it can't find the reference. That's because you haven't compiled it in this case, or linked to it. So because you can see here, it's the linker that's complaining. That's what this stands for. All right. Anyway, so now we've included it. We now have this program. We can't find the reference, and so what we could do is, let's say we include the actual path to the file. So it's going to compile this, but then also compile, we're doing the full path, but dependency source load.cpd. That's right. And then, so now we gave it the file. We don't have any compile errors. When we check, we can run it. There. So hello from dependency one. So instead of writing long G++ commands or GCC commands, we can instead use a Makefile, and then there's also cmake, but a Makefile is better for smaller projects and is itself included as one of the outputs of cmake. So I'll start with the Makefile. And the idea here is that same command we just run is now represented by this target. So after you install make, I already have it, but after you install it, you can then make, and then it will autocomplete for you the various targets you have written with this colon here. And the whole idea with make is you pick dependencies in the order at which you want certain operations to run. So I'll even make just a stand-in target. So let's say it depends on nothing. So you can just say, all it'll do is say hello from something else. So make something else, hello from something else. And then we add run first. How about run before something else? And the target hasn't been created. So in this case, it says the target's not there. And I believe if I do which, never mind. I'll just do it in terms of targets. So this, say, pair or something else. See, so, okay, so we'll get rid of this. And now I'm going to make a little app, and I'll remove now this run first, because we know what it does. So this has no dependencies. Make a little app, and it did the same thing, but we kind of still have this issue where we're specifying files, and the whole idea is that usually the dependency has been packaged for us, so we'll make it one step more concise and at the same time show what a cmake list is. So we'll go to this folder, and instead of a Makefile, and instead of all the console commands, we're going to use a cmake list file. Okay, and by cmake lists, what I mean is the tool cmake, which is similar to make, but is good for large projects. So I made another hello world folder here where we have a build directory, which usually starts empty. We'll just delete it, and we have a source directory where, again, all we're doing is printing hello world. And we have essentially the minimum amount of lines in our cmake list to actually use the tool cmake. So usually we do cmake, point it to where the cmake list is. In this case, it's one directory above because I'm in the build folder. And it hasn't actually built the target yet. It's just made a makefile, kind of like the makefile we just had, except it's just auto-generated it. And it comes with targets like clean, for example. But to actually make our app, which in this case, it's usually to use the term target. Generate it. Make. So we built the app. Okay. And you can see it's come with some make targets for us, like make clean got rid of the app. Okay, and by cmake lists, what I mean is the tool cmake, which is similar to make, but is good for large projects. So I made another hello world folder here where we have a build directory, which usually starts empty. We'll just delete it, and we have a source directory where, again, all we're doing is printing hello world. And we have essentially the minimum amount of lines in our cmake list to actually use the tool cmake. So usually we do cmake, point it to where the cmake list is. In this case, it's one directory above because I'm in the build folder. And it hasn't actually built the target yet. It's just made a makefile, kind of like the makefile we just had, except it's just auto-generated it. And it comes with targets like clean, for example. But to actually make our app, which in this case, it's usually to use the term target. Generate it. So we built the app. Okay. And you can see it's come with some make targets for us, like make clean got rid of the app. Now I'll go over the same example as we did before, where the app prints hello from our main function here, and then also hello from what I'm going to call a dependency. But in this case, I mean, this is the same as if it was all in our own project, where, again, we just have one executable. I've literally pointed it to the source file. And for the include directory, I've done the same thing. I've pointed it to the header. And I just want to show that it compiles everything. So I'll just start over. See, so here it actually had to compile the dependency, where typically, in a lot of cases, what you instead have is a shared object that could do the functionality for you. So there's a lib.so. So here we can see these are all these shared objects that can be shared between applications. And so we're going to do the same thing for this dependency. So instead of it getting printed, we're going to turn it into a shared object. So we go to the cmake lists here, and this is all in its own folder that I've called dep1 for dependency1. So again, our source is just the header that has a function that says say hello, and it has no main. Note that actually it couldn't compile itself as a program because it doesn't have main, but it can be compiled as a shared object. So now for the cmake lists, remove all this. So this is for a different tutorial. Okay, so now it's not add executable, it's add library. We're going to give it a name. It's just going to be called hello. It's shared. And you can start to get used to these environment variables that are available to you, such as project source directory. And so that's what it sounds like. The project source directory point to the source file. And I only had this to when I was doing a cross compilation example, but sysroot is essentially what it sounds like. It's the system root. And for this tutorial, we don't have to talk about it. In any case, we have add library, and this is actually, I believe, the only line we need in this case. So let's go to this folder. I'll just start from scratch. And build. Okay, so now we have a shared object. And I'll link to it manually first. So we'll go back to our cmake lists for our main app under Hello World. And I guess I'll keep the include directory for now, but we're going to remove the step where it compiles this code. And instead, we're going to call target link libraries. And just to make it obvious what we're doing, I'm going to go to the dependency and literally take the path of what we just built. And now again, so all we have is our source code that includes the header that we need. And then we're going to include that point to the path where that header is. And then link to the shared object that has already been built. I think this will work. See, so it says hello from dependency one. But this can also get messy because we're pointing to a custom directory for include. We have the path here for our shared object. So another way to do it is in the dependency, we're actually going to add these install targets. And what it's going to do is move the library hello we just made into the destination of user/lib. And that's where I showed that there was a lot of other shared libraries. So we're going to put them in the same place. So we're going to put them in user/lib hello. And we're going to put the header file there too as well. And you'll see user include. Again, this is also a location where there's many header files typically put. So we can group them all together here. So I'm going to go back to the dependency path. Now I'm back in the folder to build a dependency. And now they haven't been actually moved yet. We have to call the install target. Oh, I didn't click save. That's what happened. Okay, click save. Make install. There's some permission issues, so sudo make install. So now you can see the library is in that path with all the other shared libraries, and the header has been put there as well. So we go back to our app, and instead of having like a custom directory for all dependencies, we can just instead just include that path. all the other header files are, and you can even look for a library. So here we're going to say find library. We're going to call it hello lib. That's relative to the file we're currently in. Names, it's going to be called hello. And by convention, because this says lib hello.so, that's how it knows the name is hello. So it drops the lib part. And it's going to only look within user/lib. And in this case, we placed it in user lib, but it could have been one directory above, and I think it will still find it actually. Let's try. And so if it finds it, it'll say it found it. If it doesn't, you can print a message saying it did not find. So let's try this, copy path. Okay, so it could not find it. Let's see what happens if we. Yeah. Okay. Okay, so now you can see, again, it still works, but we've cleaned it up a bit by having more common folders. Okay, so that's all I wanted to show in this tutorial. The next thing I wanted to show is that typically you can get into situations where, if you recall, when we were building it, it also had to compile the dependency path. And I think in general, for large projects, you'll have this situation where you want to build for an embedded device like a Raspberry Pi, and it just makes more sense to have a host machine that you build on and then deploy it to Raspberry Pi. But the issue there is that if we log into my Pi, for example, I think it's and remove the old files, but if we copy over the app we just built, shell copy app. Okay, so I just copied over the app on the Raspberry Pi, but if we try to run it, let's say format error. And that's because it hasn't been compiled for the right architecture. So we can say file, my app, and you can see it's for an x86 architecture. But we are on an ARM device, which is the Raspberry Pi. So I wanted to do a follow-up tutorial on how you would cross-compile. And that's all I wanted to show for today. Thanks for watching.